Okay, so we're going to finish up section 13.5 by working out two more problems with spatial substitutions. So as you can see on this page, w is a function of three variables, x, y, and z. X is a function of theta squared, y is a function of r and theta, z is a function of r and theta. We are interested in learning how much is del w del r and del w del theta. First, we will use chain rule. So as usual, we'll say del w del r is going to be del w del x times del x del r plus del w del y times del y del r plus del w del z times del z del r. So let's find it first. Del w del x. Since x is the only variable, y, z are constant, your derivative is going to look like minus yz over x squared times del x del r. Well, that's 0 because x doesn't have any r in it. Then I do del w del y, which is going to be z over x, and del y del r, well, it's 1. Del w del z is going to be y over x, del z del r is also 1. So the first term I don't have to worry about. Z is r minus tan theta over x is theta squared plus r plus tan theta is y over theta squared. Since you have the common denominator, combine the terms, you get r minus tan theta plus r plus tan theta over theta squared. So clearly this one is 2r over theta squared. I will write it down. This is 2r over theta squared. Then I'm going to find out del w del theta. So del w del theta is similar. It will have similarity in del w del x, except this time you will multiply by del x del theta. Again, similarity in del w del y, but multiply by del y del theta plus del w del z times del z del theta. So our derivatives are going to be a little different. So those things we know, del w del x, we have already worked it out. This is going to be minus yz over x squared. Del x del theta, because x is theta squared, you will get 2 theta. Del w del y we know, it's z over x, and del y del theta is going to be positive 10. And then plus del w del z is y over x, del z del theta is negative 10. Replace all your x, y, z in terms of r and theta. So you get minus r plus 10 theta for y, r minus 10 theta for z over theta squared squared, so I get theta to the power 4 times 2 theta plus z is r minus 10 theta over theta times 10 plus y over x is r plus 10 theta over theta squared, x is theta squared, times negative 10. So let's simplify this. First and foremost, I want you to understand that I will cancel this theta with one of the theta in the theta to the power 4. And on the top, I'm going to get minus r squared minus 100 theta squared multiplied by 2 over theta cubed plus 10r minus 100 theta over theta squared minus times plus is minus 10r plus 100 theta over theta squared. Let's see whether we can simplify this thing. So for the common denominator, the second term and the third term will be multiplied by a theta on top and bottom. So I will get minus 2r squared plus 200 theta squared. Then I will get plus 10r minus and 10r theta minus 100 theta squared minus 10r theta minus 100 theta squared when I multiply theta on top and bottom for the second term and the third term all over theta cubed. So the 10r theta and minus 10r theta will cancel each other, and I will get minus 2 times r square, and you have 200 theta square minus 100 theta square minus 100 theta square, so cancel, over theta cubed. So that is the derivative minus 2r squared over theta cubed. Now we're going to check whether we have done the work right, and the way we're going to check, we're going to convert w in terms of theta and r before differentiating, simplify, and then differentiate. Now remember, w is x times y times z. I'm so sorry. It's y times z over x squared. Your y is r minus 10 theta. Your z is r plus 10 theta over theta squared, which is r squared minus 100 theta squared over theta squared. So when I do del w, del r, the work is pretty easy because theta squared is the constant on the bottom, so it will not be treated in the derivative, whereas the derivative of the top is just going to be 2r, because 100 theta squared with respect to r will give you the derivative of 0. So I get 2r theta squared, which matches with my answer in the previous process, so we have done both of them right. Now we're going to find del w del theta. This one is a little difficult because theta squared is on the top and bottom, so I am going to use quotient rule. The way I'm going to write it, I will say the top derivative of that times the bottom minus the top r squared minus 100 theta squared times the derivative of the bottom over the square of the bottom, which is theta to the power 4. Derivative of r squared with respect to theta is 0, but derivative of negative 100 theta squared is negative 200 theta times theta. Then you have minus r squared minus 100 theta squared. Derivative of theta squared is 2 theta all over theta to the power 4. So I get minus 200 theta squared minus r squared times 2 theta plus 200 times theta to the power 3. And in fact, if you think of it, it should have been a theta squared, so that should be a theta cubed as well. And this term is all over the theta to the power 4 on the bottom. So let's see how we can simplify that. As I can see, I have negative 200 theta cubed and positive 200 theta cubed. They cancel each other. So you get minus 2r squared theta over theta to the power 4. Theta cancels from top and bottom. And I get minus 2r over theta cubed. Did I get the same answer in the previous process? Well, we did. It's minus 2r squared over theta cubed. So we have the same answer from either processes, kind of satisfying me because now I know that I have done both of them right. All right, so we have only one more problem that I'm going to show how to do, and hopefully these problems are going to help you do your own homeworks. So as you can see, this is a little complicated looking function, so I have to be really careful when I'm working this problem out. My w is 49 minus 4x squared minus 4y squared. X is a function of r and theta, y is a function of r and theta. And these are spatially important substitutions. They're polar substitution, which will be very important for us to understand when we do integration with multiple variables. So first, chain rule. So we're going to say, I'm interested in finding del w del r, which of course is del w del x. As you can imagine, the derivative is not going to be simple, times del x del r plus del w del y times del y del r. So let's try to understand. Del w del x, you will treat it as a square root function. So first and foremost, you will get 1 over 2 times square root of 49 minus 4x squared minus 4y squared. Derivative of the inside, but with respect to x, so I'm going to get minus 8x times del x del r, and del x del r is just going to be cosine of theta. plus we do del w del y, derivative is pretty similar. You will get 1 over 2 times the square root part, 49 minus 4x squared minus 4y squared. Then derivative of the inside with respect to y, so I get minus 8y times del y del r is sine theta. So let's simplify this much. So I get 1 over, I see the denominator is common, so I'm going to write it only one denominator as 49 minus 4x squared minus 4y squared on the bottom. And then on the top, I have negative 8x, so negative 8 times x is r cosine theta times cosine theta. And then you have plus times or minus is a negative as well. So 8y, which is r sine theta times the sine theta. Is this a little better looking is what we are interested in. So we'll say that, well, this is equal to negative 8r cosine square theta plus sine square theta. When I factor out the negative 8r out of both terms, what is the bottom? It is 2 square root of, unfortunately I have to change it to r and theta, so I'll say 49 minus 4, factor it out. X squared is r squared cosine square theta plus y squared is r squared sine square theta. So I get cancel 2 and 8. I will get minus 4r on the top. Sine square theta plus cosine square theta is just 1. On the bottom, I'm not going to get that ugly of a term because you will have 49 minus 4r squared. Then you see the rest is just cosine square theta plus sine square theta, which is 1. So I'm pretty much done. And in fact, I don't have this 2. I cancel this with the 8 on the top. So this is what seems like my del w del r. So del w del r, I'm going to go ahead and say minus 4r minus 4r over square root of 49 minus 4r. Let me check. I think that's r squared on the bottom. R squared. Now we are interested in del w del theta. As I have said, this is going to give us a little trouble. So again, this is del w del x. This portion we have done times del x del theta. And then we will have plus del w del y times del y del theta. Del w del x and del w del y are known to us. These are minus 8x over square root, 2 times square root of 49 minus x squared, 4x squared minus 4y squared. And then you have del x del theta. So x is r cosine theta. Derivative of that with respect to theta is minus r sine theta. Minus r sine theta. All right. Plus del w del y is minus 8y over 2 times square root of 49 minus 4x squared minus 4y squared. And then I'm going to multiply this by del y del theta, y being r sine theta, the derivative is going to be r cosine theta. So times r cosine theta. So let's think about the top. You have minus 8x, which is minus 8 r cosine theta times minus r sine theta. Then you have minus 8y, which is r sine theta times r cosine theta. All over 2 times square root of 49, as we have done earlier. I will factor out the 4. X squared will be r squared cosine square theta, and y squared will be r squared sine square theta. But I think I have a good news on the top. If you look at the signs, then you will see minus times minus in the first one will make it a positive 8r squared cosine theta sine theta, whereas you have minus 8r square cosine theta sine theta from the second term, which together is going to give you 0. And the bottom is just 2 times square root of 49 minus 4r square. Once I factored out the r square, I get cosine square theta plus sine square theta, which is 1. So this is eventually equal to 0. Hard to believe. I might have done some mistake, but we will be able to check it. As you know, now your target is to rewrite w in terms of r and theta, then take the derivative. So we'll go back to the form of w. W is square root of 49 minus 4x squared minus 4y squared. So let's see that. W is square root of 49 minus 4x squared minus 4y squared. And we have been substituting properly for x and y. So 49 minus take 4 out. X squared is r squared cosine square theta. Y squared is r squared sine square theta. And then I factor out the r squared. So I get square root of 49 minus 4r squared. That's your w. So when I do del w del r, I am doing the derivative with respect to r. So I get 1 over 2, the square root term, 49 minus 4r squared, times the derivative of the inside with respect to r is going to be negative 8r. So we get minus 4r over square root of 49 minus 4r squared. And if I do del w del theta, notice one thing, your w term doesn't have any theta. So that is going to be 0. So we have done this one right as well. I'm just going to write these answers. This one was minus 4r over square root of 49 minus 4r squared. We found in both processes, and this one was 0 in both processes. Which concludes our study of chain rule in partial differential equation. And we are going to next time talk about the directional derivatives and gradients.